Hi, my name is Alexia Huang, and we're happy today to introduce you to the web app that we developed, RicEats. We are a team of 4 RICE sophomores passionate about improving RICE students' dining experience. Let's think about this scenario. When you want to eat dinner on Sunday, September the 19th, 2001, and you go into the dining.rice.edu website to take a look at the menu there, and you found that the fonts are very small and there are a lot of dishes listed. And you have to walk through every one of them and compare each of them to find out the dish that you like the most and the server that you want to go to. If you want to plan ahead for dinner, then you have to click another individual server's website to check out their menu, and you have to go back and forth to compare dishes, which is extremely inconvenient. We did a quick survey to some RICE students, and among the responses, 92.9 says they're willing to see improvement in the current website. Therefore, we built RicEats, which is a useful app that can help students decide which server to go to, recommend dishes to them based on their personal preference, and allow them to rate and comment on the dishes they have, which is extremely user-friendly. Without further ado, let's walk through the app.
Hi everyone, my name is Cuiyuanxiu and I'll be introducing our web app demo to you. So as you can see, this is our homepage. I can click here to check out today's menu. It's Sunday, so bakery doesn't open. It includes lunch and dinner. So if I go back and log in, I can log in with my personal email. Log into account and it will turn to a page that asks me to input my personal preferences. Say, I like corn and carrots. I like chicken and what I hate is mushrooms and seafood. I can also pick my favorite flavor, like say sweet. I'm allergic to peanut, so I want to avoid eating peanut. Okay, so I can submit. Then according to what I just entered, our web app will automatically generate the best server recommendation for me. So as you can see, it recommends me to go to west for lunch and north for dinner. From here, I can also rate the dishes that I had. So our web application will automatically grab those data and make better recommendations according to all the past ratings. Okay, I can also see this is our beautiful about page that describes our mission. So I can also log out. So that's our demo.
So our website is hosted on Firebase. All of our server data is stored using the real-time database.
So to get all the information about dining, we use Chrome and Chrome Drive to do web scraping on Rice Dining website. Since there are dishes that are the same but do not have the exact same name, we categorize them by keywords such as ingredients or flavors. This information will also be useful in later process of recommendation. One key feature of our project is to recommend dishes and serve it to users. So we need a recommendation algorithm. There are 3 useful models. The popularity model, which simply recommends the most popular dishes to the user. However, it is clear that this model is not personalized. Therefore, we introduced the second and the third models. The second one is content-based filtering model, which gives recommendation based on the user's previous behaviors, and in this case, their previous reviews. Specifically, this model uses the technique frequency inverse document frequency that converts a natural language text to a vector structure, which allows us to determine the relevance of 2 dishes based on their names and keywords by calculating the cosine similarity of the corresponding vector structures. The last one is collaborative filtering model. This model not only takes the user's profile, but also other users' behaviors as well. Generally speaking, it assumes that users with similar reviews in the past will likely to like similar dishes. In this algorithm, we use singular value decomposition to do matrix factorization to reduce the sparsity of our data. After getting all of the information from 3 models, we give weights to each recommendation and combine them together to have a hybrid model, which behaves better than individual ones.
And we also use Firebase to do our hosting by connecting it to GitHub. We also use Firebase for authentication. As you can see, we use the real-time database, which is a NoSQL database, and to store all of our different food options for the week that we have pulled from the Rice Dining website. It is organized into as such. These numbers correspond to the food item, which can be found here.